Hi everyone, today I'm going to explain the phases of action potential and how signals move through a neuron. I'll also explain one nervous system disorder related to this process. Let's start with the resting membrane potential. When a neuron is resting, the inside of the cell is more negative than the outside, about negative 70 millivolts. This happens because of the sodium-potassium pump, which moves 3 sodium ions out and 2 potassium ions in. That difference is in charge keeps the neuron ready to send a signal. Now the receptive segment, that's the dendrites, and cell body, the neurons, receive signals from other neurons. These incoming signals cause small voltage channels called graded potentials. If a signal makes the cell a little more positive, it's called excitatory. If it makes the inside more negative, it's inhibitory. All these signals combine or sum up at the initial segment, which is also called axon hillock. If the total changes at hillock reaches the threshold membrane potential, about negative 55 millivolts, the neuron fires an action potential. This follows the all or none law, which means it either fires completely or not at all. Now let's look at the action potential itself. First comes depolarization. The sodium channels open and sodium ions rush inside, making the inside of the cell positive. Next is repolarization. Potassium channels open, allowing potassium to leave the cell and return toward a negative state. Sometimes the cell becomes even more negative than normal, which is called hyperpolarization. Then the sodium-potassium pump restores the normal resting potential. During this process, the neuron briefly enters a refractory period. The absolute refractory period means no new action potential can start, and the relative refractory period means it takes a stronger signal to fire again. This ensures signals travel in one direction. Next is the conductive segment, which is the axon. This is where the action potential travels in unmyelinated axons. The signal moves step by step, known as the continuous conduction. In myelinated ions, the impulse jumps from one node of nerve to the next. That's called saltatory conduction, and it's much faster. Finally, the signal reaches the transmissive segment, which is the end of the axon. Here, calcium channels open, calcium flows in, and this causes the release of the neurotransmitter, actually ACH. ACH across the synaptic cleft and triggers a new signal in the next neuron. Now, when something goes wrong with this process, the effects can be serious. A good example of multiple sclerosis, or MS. In MS, the immune system damages the myelin sheath around axons. This slows down and blocks the nerve signals, leading to symptoms like muscle weakness, vision problems, and balance issues. Thank you.